Hello and welcome to this Controlsoft iNet door controller overview. In this video overview, we will look at all the key components of the iNet controller, which will help you to understand how it can be set up and configured with the identity access software and associated hardware. Some of the key features of the iNet door controller are as follows. The iNet will control two doors when using reader in with request to exit, or one door when using reader in and out. It can be connected via IP or RS485 and supports Wiegand or OSDP readers. With 9 programmable inputs and 4 relay outputs, it is an offline controller with fully distributed intelligence. It is UL 294 accredited, which is identified by its clear plastic cover shown here. So let's now look at the iNet in more detail. Starting at the bottom left-hand corner, you will see 3 red LEDs. When these are all lit up, power is connected. Next to these power LEDs, you will find the 12-volt power connection. This typically connects the built-in power supply, which is included if you purchase one of the following part numbers shown on screen. An orange system light located here will illuminate when the iNet has completed its boot-up process. To the right of the power connector, you'll see 2 RS485 connection ports labelled A and B. Port A is used for Controlsoft I/O expansion boards and other 485 devices, such as HID OSDP readers and Aperio wireless locks. Each 485 device added onto port A must have its own unique 485 address. We recommend using a Belden 8723 cable for RS485 connections. RS485 devices must be wired as a multi-drop or daisy chain and not as a star topology. Port B is used to connect slave iNet controllers. Connect port B on the master controller to port B on the slave devices in a daisy chain using a Belden 8723 cable. Each slave controller needs to have a unique address. We will show you how this is achieved shortly. Once all the slave iNets are connected and powered up, you will notice that the RX and TX lights above the terminal blocks will start to pulse red and green to indicate the data is being transmitted and received. Please make sure that all master and slave controllers are operating on the latest firmware version, which can be obtained from our website, controlsoft.com. When not using slave iNet controllers, the TX light will be pulsing red to indicate that the iNet's onboard operating system is now running, and the iNet is attempting to poll for slaves. Every iNet holds its own onboard database, so in the event of any loss of network connection or RS485 connection, the controller can work offline. The two-way dip switch here is used for termination of the RS485 bus. This needs to be switched on for the first and last device on the bus when you are using a fairly long 485 bus line, anything over 100 meters typically. Now let us look at the right-hand side of the iNet. At the bottom right you will see 2 Wiegand reader connectors. The iNet can be used as a single door controller with a reader in and out, or as a 2-door controller, with each door having a reader in and a request to exit button out. The Wiegand ports are power limited, which means you cannot use them to power high current devices, such as locks or fingerprint readers. These must be wired into the power supply. We recommend using a Belden 9538 cable for your Wiegand connections. 12-volt Wiegand readers can be powered from the iNet's Wiegand ports up to 25 meters away. You can extend the Wiegand reader's wiring up to 80 meters away from the controller, but anything over 25 meters, you may require a power supply local to the reader. Above the Wiegand ports, you can see 4 relay outputs, 0 through to 3. Here you would connect the locks for door 1 and 2. You could then use one of the auxiliary relays to trigger a sounder for a door alarm, for example. The LED will illuminate in green color to indicate that a relay has been activated. This image shows an example on how to wire in a Breakglass to the outputs with a Maglock. Now looking at the top of the iNet, you will find its serial number. This may sometimes be requested by the Controlsoft support team, so it's worth keeping in mind where to find it. For legacy version 1 and version 2 controllers, you will find the serial number on one of the relays. Next, towards the middle of the iNet, you will see a cutout in the plastic cover where you can find the controller's MAC address. The MAC address will be shown in the software when the controller has been added via the IP scan feature. It is worth making note of the MAC address when installing, so you can tie the physical controller and the software together. Also, some customers' network setup may require the MAC addresses to be whitelisted, so you may be asked for a list of MAC addresses by the IT team. The four-way dip switches here are used to enable or disable the two RS485 connectors, A and B, that we spoke about earlier, and also they are used to enable or disable the onboard Wiegand readers. Switches 3 and 4 are not used, so must be switched off. By default, our iNet door controllers are pre-configured for port B, iNet to iNet operation with the Wiegand reader ports also enabled. We discussed earlier that each slave iNet controller requires a unique 485 address. This is achieved by using the Rotary Switch located here. Master iNet controllers must always remain on address 0, which is reserved for the IP connection to the software. Each slave device can be addressed from 1 to 15, so you can expand the master controller with up to 15 slaves and a maximum of 32 doors. The main benefit of using a slave iNet controller is in situations where there is no IP network infrastructure available in the location where you want to install additional door controllers. A Cat5 network cable will only typically reach up to 100 meters point to point, but when using RS485 you are able to connect devices up to 1 kilometer away from the master controller. The reset button located here can be used for either rebooting the controller when pressed and held for 5 seconds, or if the reset button is pressed and held for 30 seconds, this will reset the controller's IP to 10.0.1.230. All of our iNet controllers are shipped out in DHCP mode, which means they will automatically obtain an IP from a network switch or router. If this isn't possible, then you will need to reset the IP to a fixed address as explained using the reset switch. Now let us look at the left-hand side of our controller. In the top left-hand corner of the iNet, we can see the Ethernet port. This is how the master controller connects to the network. A green flashing LED will indicate that traffic is being received over LAN. The IP controllers work in peer-to-peer mode, meaning they do not communicate through the PC server, and each iNet has a full onboard database to provide fully distributed intelligence at the door. If you wanted to check if your RS485 slave connections are live on the master controller, you can enter the IP address of the master into a web browser of a machine which is on the same network, and from here you are then able to check the EMS status page. The EMS status page shows which of the slaves are online, indicated by a number 1 underneath the address, and which slaves are offline, shown by a number 0 underneath the address. Below the LAN connection, you will see a set of input connectors. There are 9 available inputs on the version 3 iNet controller. Inputs 0 to 3 are where we connect our request to exit and door contacts for door 1 and 2. Triggering each input will illuminate the adjacent LED in red. This means that you are able to check the input is operating correctly. Moving higher up, we have input 4. This is where you can connect your fire panel if required. When the fire input is configured in the software, the fire panel will send a signal to the iNet, which can then unlock a required set of doors, and also automatically print off a fire roll call report to your default printer if you are using the professional or enterprise version of Identity Access. Input 5 is used for mains or power supply fail. This will send an alarm over to the software to inform you that the power supply has gone off. When the PSU fails or there is a power cut, the iNet ideally should be powered by a backup battery to prevent any downtime. Input 6 is for monitoring a tamper alarm. The tamper switch is installed on the ACU cabinet for you if you order this part number. When configured, the input will send an alarm over to the software and generate a local alarm at the controller, informing you that the cabinet has been opened. Input 7 is used for battery fault, which again can be configured to generate an alarm. And input 8 is a spare input, which can be utilized as an additional request to exit or for actions and events. All listed inputs are fully configurable in Identity Access software, so can be changed if you are not using these functions. Thank you for taking the time to watch our iNet overview video.